Hey everybody, thanks for tuning in to this little math video here. And this one, I'm calling the title of this video is Solutions Equal X-Intercepts because that's kind of the point that I want to make. Hopefully this will be a pretty short video. The point that I'm trying to make here, folks, is that when you solve a quadratic equation, and that is when you find its solutions when it is set equal to 0, when you do that, that's exactly the same thing as finding the x-intercepts of a parabola. The algebra that you do is exactly the same, and so you are actually doing the same thing. When you solve an equation, you're also finding the x-intercepts of a parabola, and that is not a coincidence, okay? So let's do one here, and I'll show you why it's not a coincidence and why it's actually exactly the same thing. So here's an equation I thought I'd just set up for you to solve here. X squared minus 5x equals negative 6. Well, that equation is not set equal to 0. Okay, so in the first thing I want to mention, and we haven't seen too many examples of this, but I want to take this opportunity to show you this. If it's not set equal to 0, well, that is the first thing you take care of. Okay, set the thing equal to 0. And so when you set that equal to 0, you get x squared minus 5x plus 6 equals 0. And so we're going to solve that by factoring, and our diamond problem here leads us to this solution right here, x minus 2 times x minus 3. Well, that's the factors of this, x squared minus 5x plus 6. So that gives us our factors, and we set those factors equal to 0, and we come up with x equals 2 and x equals 3. Okay, cool. We solved the equation. We got the solutions. Now, what I want you to think about at this point, though, is let's say we have a parabola. And let's say the equation for that parabola is y equals x squared minus 5x plus 6. All right? Well, what if your job, all right, here is to find the x-intercepts of the parabola? Well, at the x-intercepts, all right, y equals 0. Okay? That's the important thing to think of. At the x-intercepts, let me put it this way. At x-intercepts, y equals 0. So, if I want to find the places where y equals 0, what I'm going to do is I'm going to substitute 0 in place of y. So I'll have this. 0 equals x squared minus 5x plus 6. So that's why it's not a coincidence that you get the x-intercepts when you solve the equation when it's set to 0. Okay? All you're doing is taking this y equals for the parabola and replacing the y with 0. And when you do that, we've already figured this out. So x equals 2 and x equals 3. That means that if you were going to graph this parabola, now we have 3 points that we know because the equation itself gives us this, well, let's just say it's right here. This point right there, if you remember right, that is the y-intercept, all right? So let's say that's right about here, okay? Let's say that's 6 on the y-axis. Now our x-intercepts are 2 and 3. So there's 2, let's say, and there's 3. Okay? That means this parabola kind of goes sort of something kind of like this. All right? There's your x-intercepts, 2 and 3, and your y-intercept, positive 6. All right? And so every time we do this, every time you solve a quadratic equation set equal to 0, you're doing exactly the same algebra. All the stuff we did right here is exactly what we would do to find the x-intercepts if we replaced y with a 0. Okay?